Hi, morning year 12. I'm just going to talk you through Wilcoxon T, okay, and how to do it. So there's our decision tree. As you can see, Wilcoxon T is here, okay. So our three decisions, remember, is that we've got a test for difference. So we've got an experiment of some kind in terms of our design, our experimental design. Our data has to be related. So we've got here something like a repeated measures design. You could also use matched pairs, okay, because that would be treated as related data. And our level of measurement would be a scale of some sort, either an ordinal scale or an interval scale. Okay, so that's our decisions. And what you need to do whilst I'm talking through this is follow the information that's in the workbook that you've been given. Okay, so use them in conjunction with each other and then the example will start to make sense. So our next job is to state the hypotheses. Okay, so we have two hypotheses and we've got a dichotic listening task here. Which you would have encountered in core studies. So what we're going to predict is a sort of directional hypothesis. Yeah, so we've got a one-tailed hypothesis that's going to predict that participants will correctly recall a higher number of words in the ear that they use to hear the words during the dichotic listening task. Okay, so our variables are clear. We're saying a higher number of words and we're stating the direction of change. And then our statement of no effect, our null hypotheses, we're saying that there's going to be no difference, yeah, between the ears in the number of words correctly recalled during the dichotic listening task. Okay, so your next job is to calculate your observed value. Okay, so you need to construct a table, okay, which looks something like this. We've got our raw data, yeah, in these first two columns here. So we've got our participant and we've got their recording for their left and their right ear, and we've added in two extra columns. Okay, we've got a difference column and we've got a ranked order of difference column. Okay, so that's your first job. Just going back to the instructions. So 3, yeah, point 3, it's asking you to find a difference between each condition. Yeah, so that's the difference column. And then once you've done that, you're going to rank the differences from low to high. Okay, but there's some rules here in that you don't, you don't really treat minuses and pluses differently. Okay, so positives and negative signs are just going to be ignored. So a -1 and a +1 would be the same. Okay, so ignore the signs for now. Okay, and again, the other rule is, there's quite a few rules to remember, is that if you get a tied rank, okay, so you get lots of differences the same, then you apply the tied ranks equation where you find the average of the ranks, okay, like we've done in class before. So in relation to our example, yeah, so for participant 1, we're going to look at the difference first, yeah, that difference column, and we've got that value from taking 33 from 5, which has given us -28. Yeah, for participant 2, we've taken 26 from 10, and that's given us -16. Okay, and then what we do is once we've got all our differences, we rank them, okay, from low to high. Another rule that you need to remember here is that we're going to ignore 0 differences. Yeah, so as you can see, participant 5 has a 0 difference. We're going to ignore that, yes, perhaps cross through it so you know that you're not doing anything with it. And what you need to remember is when you find your critical value later in the table, okay, you have to reduce n accordingly. Okay, so in this instance, we've got 9 participants. We're discounting one of our scores. So when we go to n later, it's going to be 8, not 9. Okay, so you need to remember that rule. Yeah, and similarly, you need, as I've said previously, remember your tied ranks. There's none here in this particular instance. And remember to ignore the signs when you do your ranking. You do need them for the next step though. Okay, you do need to go back to them. So once you've done that, once you've got that table completed, what you're going to do is, as it says, number 5, find the observed value of T, which is the sum of the ranks for the less frequent sign. Okay, so here you go back to your signs, okay, and you count up the number of positives that you have and the number of negatives that you have. Okay, so you're not doing the difference, you're calculating the ranked order of difference. Okay, so for instance, our pluses added up, yeah, which is the less frequent sign, would be 7 plus 4 plus 3. Okay, so we're calculating the sum of the ranks for the sum of the ranked order of difference for the less frequent sign. Okay, so we're going to go 7 plus 4 plus 3. So that calculation, okay, of the less frequent sign here is our observed value of T. Okay, so that's that. Okay, so 0.5, find the observed value of T, which is the sum of the ranks for the less frequent sign. And then after you've got your calculated value, you're going to go to your critical values table, okay, which they'll give you if they want you to do anything with it in the exam. And you remember you need N, yeah, which is your number of scores, and you need to omit any data where there is no difference, and finally state the conclusion. So in our example, our observed value in this instance has come from adding our less frequent sign, which were the positives, yeah, calculating their, adding up their ranked order of difference. So we've got 7 plus 4 plus 3 equals 14, okay, and then we go to our critical values table, which is given there. So N, remember, is 8, not 9, because we've omitted that 0 score, so 4 is our critical value, okay. So we've got a 14 and we've got a 4. So the rule of R says Wilcoxon doesn't have an R in its name. So our observed value has to be equal to or less than the critical value for significance to be achieved. So in this instance, we haven't got a significant result. Yeah, 14 is bigger than 4 rather than lower than 4. So we write our conclusion. Yeah, so as the observed value of Wilcoxon is 14, is higher than our critical value of 4. Yeah, the results are not significant at P equal to or less than 0.05. That's our rationale. So we're going to accept our null hypotheses, yeah, and then back to context, accept the fact that there is no difference in the number of words recalled by either ear on a dichotic listening task. And that's it. Okay, so what you need to do is perhaps work through this yourself and then do the examples that I'm going to set you. Okay, thank you.